So today we're going to talk about perpendicular and angle bisector, section 5.1. Now remember, perpendicular means two lines that cross at a 90-degree angle. An angle bisector means it cuts an angle in half. So there's two equal sides. Okay, so two key phrases there, or two key words that'll get us started. Equidistant. Equidistant means the same distance from two or more objects. So if I were to have a line here, and let's say I put this point on the line right there, what would this point be called if it were equidistant to the endpoints? That'd be called the midpoint, right? Very good. Yeah, that'd be called the midpoint. So that'd be... We all agree the midpoint is equidistant to the two sides of the triangle, or the triangle, to the two sides of the line, right? Good. So that's the big point for today. Talking about that, equidistant. Same distance to the sides. Here's what we're going to talk about first. We're talking about a perpendicular bisector. Well, let's talk about it. What's a perpendicular mean? Perpendicular means it meets at a 90-degree angle. What's a bisector mean? So a perpendicular bisector is this line right there. It cuts another line in half, forming a 90-degree angle. Does everybody see that diagram there? See how the yellow line, it comes down, it cuts the line in half, forming a right angle. So for example, let's say like this. Would something like that be a perpendicular bisector? No, why? Because it doesn't come down at a 90-degree angle, right? It's got to be a 90-degree angle, okay, and it has to cut the other segment in half. Now, what's important, or what's unique about a perpendicular bisector? If a point is on the perpendicular bisector, then it is equidistant from the endpoints of the segment. So everything along this line now is equidistant to the endpoints. Okay, so it's kind of unique. All right? And then we're going to focus on this part tomorrow. That'll be tomorrow's lesson right there, kind of doing those equations. All right, so let's look at number one. It says find each measure. Now, it starts off, M is a perpendicular bisector. How do I know M is a perpendicular bisector? I have a 90-degree angle, and what do I know about my two sides? They are the same distance, right? Great. So perpendicular bisector there, good. Okay. I want to find RT. So here's RT. What would RT have to be now, Chris? 16. Why? RS is 16, so that has to be 16. Great. Now, another question here. This one wasn't asked, but I'm going to ask you anyways. Okay. What would VS be? Who can tell me what VS would be? Claire? 14. Great. Now, let's think about what we learned last chapter. Could anybody tell me why those two triangles would be congruent? Without knowing any other side lengths, you're given this side length, you're given these angles, and they share the side in the middle. What would that be called? What would it be? That'd be side angle side. Remember doing that last chapter? Good, side angle side there. So again, we're going to start incorporating kind of all that stuff into this chapter. Okay. 2, I need to find AB. So I need to find AB here. D is a perpendicular bisector, or sorry, line T is a perpendicular bisector. What's AB going to be, Trent? He says 5. Why is it going to be 5?
Because D is the same as 2.5.
Yeah, this side's going to be 2.5 as well. And now with the whole segment, right? 2.5 plus 2.5 gives me 5. Nice job. Ty, what would CB be? He doesn't ask me for it, but what would CB be? 4. Nice job, right? Because the other side's 4. Good work. Now, number 3, I need to find HJ. So I want to find HJ here. Well, how would I set up to find HJ? Rennie, what do you suppose I'm going to have to do? Set them what? I would set them equal to each other, because those are equal, right? So I'd say 3x plus 1 equals 5x minus 3, right? So I solve for x. I'm going to subtract 3x to the other side. So I get 1 equals 2x minus 3. Oh, man. So I add the 3. 4 equals 2x. I get x equals what? Now I plug that in. And what's HJ going to be then, Chris?
7.
7. Nice job. Good work. Take a couple seconds, try these 4 on your own, using the same idea. Okay? It tells me P is the perpendicular bisector. P is a perpendicular bisector. You're using that information. Try 4, 5, 6, and 7 on your own. All right, number 4. Given that line P is the perpendicular bisector of XZ, and XY equals 15.5, find ZY. What's that going to be, Luis? Nice job, sir. Yep, because if XY is 15.5, ZY would be 15.5 as well. Good job. Okay. Number 5. Given that XZ is 38, YX is 27, and YZ is 27, I want to find ZW. Rennie, what's ZW going to be right here? 19. How'd you figure that out? Yep, take 38 divided by 2. Nice job. Next one here. Given that line P is the perpendicular bisector of XZ, XY equals 4N and YZ equals 14. How would I solve that, Tyler?
You do 4n equals 14.
And then do what? N equals 3.5. Nice job, sir. All right, now the last one. This was the tough one. It says, given that XY is equal to ZY, great, WX equals 6x minus 1, and Y, or XZ, equals 10x plus 16. I want to find WZ. Randy, I see you got your hand up. What are you thinking, bud? What? Nope. I want to actually find it. Like, I want to solve, like, it's going to be like 3 or 4, like a number. Katie, what are you thinking?
I did 6x minus 1 plus 6x minus 1 equals 10x.
Katie did 6x minus 1 plus 6x minus 1 equals 10x plus 16. Tell me about that, Katie. Why did you do that?
Because 6x, it says WX is equal to ZW, so if you add them together.
Yeah. Does everybody agree these two sides have to be the same right here in the middle? So does that, everybody agree this one has to be 6x minus 1 as well? Well, if we have the whole segment, the two-part ones add up to the whole, right? So 6x minus 1 plus 6x minus 1 equals 10x plus 16. Now I can solve for x. I end up with 12x. Man, this is slow today. 12x minus 2 equals 10x plus 16. When I work it out, I think I end up with x equals 9, don't I?
Yeah.
I end up with x equals 9. Now I plug that in. I want to find ZW, which is going to be 53. Nice job. Okay? Notice that one. You'll see that one again someday. Okay? And yeah, recognize. If they're the same segment, make sure you put them the same. Okay. Next part here, angle bisector. Who remembers what an angle bisector does? Cuts an angle in half. So if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So again, that means these sides would then be the same. Okay, if they are the same distance there. Now the converse of the bisector theorem says, if the sides are the same, what do we know about the angle then? What do we know about the line then? Well, the line's going to be an angle bisector. Okay, so it just kind of flips it around. So let's look at number 8. I want to find EH. So first off, what do these tick marks mean down here, Chris? They're congruent. So what do you know about FH? FH is a what? Angle bisector. So that's an angle bisector. And HG is 23. What's EH going to be, Chris?
23 also.
23. Using that same information, Ty, what would FG be at the bottom there?
18.
That'd have to be 18. Nice job. Great. So number 5, I want to find the angle QRS. So I want to find angle QRS. Well, if my sides are the same here, We know about my line down the middle. The line is a what? Angle bisector. So QRT is 26. What's TRS, Chris?
TRS will be 26 also.
So what's QRS, Chris?
That would be 52.
52 degrees. Nice job. And last but not least, number 10. It tells me that WZ is congruent to ZY. If those two are the congruent, what about the line down the middle? It is a what?
Angle bisector.
Angle bisector. So what am I going to do with 2x plus 5 and 4x minus 25? Oh, what do you say, Trent? Huh? Well, how would I solve that? How do I solve for x? I set them equal to each other, right? Yep. So I'd say 2x plus 5 equals 4x minus 25. Man, it's slow. Great. Okay, now I solve for x. When I solve for x, where do I get x to equal, Blake? Just waiting for Blake. Blake's got it.
But you add 25 both sides.
Yep, I add 25 to the left and subtract 2x to the right.
So 15.
Yep. And then to find my answer, I take x equals 15 and I plug that in. 2 times 15 plus 5 gives me what, Blake?
35.
35 degrees. Nice job. Take a couple seconds, try these three on your own. Same idea. All right, let's look at number 11 here. So given that JL bisects the angle, LK is 11.4. I want to find LH. Ty, what's LH going to be? 11.4. Nice job, sir. Yep, it's going to be the same. So given the angle bisector, and LH is 26, LK is 26, and HJK here is 122. I want to find angle LJK. I want to find that angle right there. What's that going to be, Luis? 61 degrees. How'd you find that, Luis? Yep, 122 divided by 2. That's got to be 61, right? Nice job. And the very last one says, given that LH equals LK. Okay, those are congruent. So because those are congruent, what do I know about this line down the middle? Let's say what? Angle bisector. Great. It says HJL is 3y plus 19. And LJK is 4y plus 5. Katie, how would I solve that?
I did the rest of them equal to each other. And then
So 3y plus 19 equals 4y plus 5. Great. When we do that, you get y equals what, Katie?
14.
Y equals 14. Nice job. Good work. And that's it for today.